So when it comes to lines in the plane, there's three things that can happen for a pair of them. Either they intersect one time uniquely, they are essentially the same line, just maybe drawn in a different way, or they are parallel lines. And for what we're dealing with here, we're dealing with systems of linear equations. That means we can either have one single solution where the lines intersect one time, or we can have infinitely many solutions if the lines are functionally the same, or we can have no solutions at all if the lines are parallel, that is, they never cross each other. So if we look at a very simple example here with the system 5x minus 2y equals 4 and negative 10x plus 4y equals 7, a pretty straightforward elimination by addition there would be to multiply the top term by 2. You'd see that both the x and y coefficients are going to cancel out and you get 0 equals 15, which can't possibly be true because those are parallel lines. If you're going to rewrite that in terms of slope-intercept form, you'd see that they have the same slope but different intercepts. Meanwhile, if we took a system like x equals 4y minus 8 and 5x minus 20y equals negative 40. For that, we could solve it pretty straightforwardly in terms of substitution. As we already have something in terms of x, we'd have 5 times 4y minus 8 minus 20y equals negative 40, which pull those terms around, simplify a little bit, and you get negative 40 equals negative 40, which is to say you've written the same line in two different ways, and you've got infinitely many solutions. Where we say that if a system of equations has one single solution, we call it consistent. If it has no solutions, then we call it inconsistent. And if we have infinitely many, we call it dependent, because we can see these solutions as depending on our relationship x, y, depending on how we define those things. So these are the three ways that our linear equations can interact, and we have similar sorts of ideas for more advanced equations, for more equations at once, more variables, things that aren't just linear, but we'll talk about that sort of thing later. For now, we're going to finish our first section here in Chapter 5 by circling back to that application we talked on at the beginning in terms of break-even points.